So welcome back to Master Academy of Mathematics. Now this is the next video session on legendary differential equation. This is the main point in the higher order ordinary differential equation. So any higher order ordinary differential equation looking in the form of a plus bx whole power n of d power n plus some p1 into a plus bx whole power n minus 1 d power n minus 1 plus so on Pn of y equal to q is generally said to be legendary differential equation. So in order to identify this legendary differential equation, the nth derivative having the coefficient a plus bx whole power n. If it is nth derivative coefficient is x power n, that comes under Cauchy-Euler differential equation. So in order to say legendary, nth coefficient definitely a plus bx whole power n. So corresponding to that given differential equation, identify the values of a and b. And you are starting with a plus bx equal to u such that du by dx equal to b. Then you are supposing dy by dx equal to b into dy by du, d square y by dx square equal to b square into d square y by du square, and so on. These values are substituted in the given differential equation to get of the form u power n d power n plus p1 into u power n minus 1 d power n minus 1 plus so on pn of y equal to q, where q in terms of u only. This is clearly a Cauchy-Euler differential equation. In order to find out that solution, start with u equal to e power z such that log u equal to z. The next is ud is replaced by theta, u square d square is replaced by theta, theta minus 1, and so on, where theta stands for d by dz. Then substitute these values in the previous equation to get of the form f of theta of y equal to q. And by that you calculate complementary function by the auxiliary equation f of m equal to 0. Then find out particular integral 1 divided by f of theta of q by using our well-known previous methods, depending on the q value, the right side value, and after getting yp, the complete solution is nothing but y equal to yc plus yp. Now let us have a problem. 1 plus 2x whole square d square y by dx square minus 6 into 1 plus 2x dy by dx plus 16y equal to 8 into 1 plus 2x whole square. So when you look at this higher order ordinary differential equation, this is the highest second derivative. What about its coefficient? It is looking like a plus bx whole power n type. So this is definitely belonging to a legendary differential equation. So comparing with your given equation with the legendary differential equation, I start with let a plus bx that is equal to 1 plus 2x. From this, what is the a value? 1, b value 2. The next step is you start with directly, I am supposing dy by dx, it is equal to b into dy by du. And the next is d square y by dx square equal to b square into d square y by du square. So these values are directly substituted in your given equation. 1 plus 2x whole square. So that value I am just writing, and condition is nothing but here 1 plus 2x equal to, I am supposing it as u. So from this, what about this du by dx value? This is nothing but exactly 2, that is exactly equal to b value. Now I am substituting in the given equation. That becomes u square into, what about d square y by dx square value? That is nothing but b square into d square y by du square. So that I can write d square y by du square, and plus that is minus 6 into, that becomes u, and dy by dx is nothing but b into dy by du, and plus 16y, that is equal to 8 into, that becomes, here it is u square. Now you just substitute the values, u square into, what about this b square value? B stands for 2, so that becomes 4u square d square y by du square minus b value is 2, it is 12u dy by du plus 16y is equal to 8u square. Now throughout this equation I am dividing with u, that 4. So u square d square y by du square minus 3u dy by du plus dividing with 4 means 4y, that is equal to 2u square. And that I am writing in the symbolic form like this: u square into d square and minus 3ud plus 4, this is of y is equal to 2u square. So this is exactly looking like some Cauchy-Euler differential equation. From this equation you start with u into d equal to theta and u square d square I am supposing it as theta into theta minus 1. Here theta stands for d by dz. So that value I am directly substituting here. So u square d square means theta into theta minus 1 minus 3 into ud means theta plus 4 as it is. This is totally of y is equal to 2 into u square value. So that I am writing here, it is u square. Now you just make the simplification. What about this value? It becomes theta square minus 3 theta plus 4. And this is of y is equal to 2u square. Okay. Now this is theta square minus 4 theta plus 4. It is of y is equal to 2u square. So, but when we are converting that into Cauchy-Euler differential equation, remember that we start with u equal to e power z. That means logarithm of u equal to z only. So that value you are substituting there. Theta square minus 4 theta plus 4. It is of y is equal to 2 into u square means e power 2z. Okay, now this is looking like some f of theta of y is equal to q. So by that you just find out the auxiliary equation f of m equal to 0. So this implies m square minus 4m plus 4 equal to 0. So by that you are getting the m values. It is 2, 2. So roots are real and repeated. So therefore you are writing yc equal to, what about the formula now? C1 plus C2 into x we should write. But everything is converted into z. So z into e to the power of 2z. Now you are finding yp, the particular integral, 1 divided by f of theta of q. This is 1 divided by, what about f of theta now? It is theta square minus 4 theta plus 4, and q stands for right side 2 e power 2z. So 2 anyhow it is a constant term. Now you are substituting, it is looking like e power ax type. So what is the procedure in e power ax? That d is replaced by a value. Here theta is replaced by a value 2. Will you get 0 here? In order to verify whether it is 0 or not, that a value, is it present in the roots? Yes. So whenever it is present in the root, definitely you will get 0 value. That you write down in the factors, that based on your calculated roots, that I can write theta minus 2 into theta minus 2. And this is only e power 2z. So it is equal to 2 into 1 divided by, it becomes theta minus 2 whole square e power 2z. Now there is no other factor to substitute that a value. So in that case, direct answer 2 into, this is as it is. This you can write the variable power 2 divided by 2 factorial. It is e power 2z as it is. So that is your complete yp. After getting that, directly y equal to, what about the yc value now? C1 plus C2z into e power 2z plus yp becomes, it is 2 is cancelled, z square into e power 2z. But actually what is z? Z is nothing but it is logarithm of u. So C1 plus C2 into log u. This is e power 2z. E power 2z can be taken as u square plus z square is nothing but logarithm of u whole square, and e power 2z can be taken as it is u square. But actually, what is the meaning of u? When we started your problem, u stands for 1 plus 2x. That u value you substitute here, you will get in terms of x variable. That is the final solution of your given Legendre differential equation. Now let us have certain exercise problems on Legendre differential equation. 5 plus 2x whole square d square y by dx square minus 6 into 5 plus 2x dy by dx plus 8y equal to 0. Right side is equal to 0. So you need not calculate yp. Only the thing is yc is enough. So you just convert into that Cauchy-Euler equation and find out your final answer. Second one, 2x plus 1 whole square d square minus 2 into 2x plus 1 of d minus 12 of y equal to 6x. This is clearly a Legendre differential equation. Start with 2x plus 1 equal to u. So by that, when you look at the right side, 2x plus 1 equal to u means what will be the x value? That you convert that x value and substitute in the right hand side and do the simplification and find out your final answer. Similarly, for the third problem, x plus 2 whole square d square minus of x plus 2 of d plus 1 of y equal to 3x plus 4. So here also x plus 2 you are starting with u only, and from that calculate x value. That x value you are substituting here. So right side, then you apply the same procedure, you will get the answer. Similarly, 1 plus x whole square of d square plus 1 plus x of d plus 1 of y equal to 4 cos logarithm of 1 plus x. Apply the same procedure, you will get the answer. So with this, your Legendre differential equation topic is closed. In the next video session, we directly enter into last topic of higher order differential equation. It is method of variation of parameters. With that, I am going to close the complete higher order ordinary differential equations. Have a good day.